peninsula, because then 0 over 0 is a hard limit. That means we cannot conclude directly. Here it's the case because ln x when x go to 1 is equal 0, because when we substitute 1 instead of x, we obtain 0. And here, when we have x minus 1, this limit is also equal 0. Then we have 0 over 0. Another problem when we have infinity divided by infinity. When we have infinity divided by infinity, that means something large divided by something large, we have a problem. Another one is 0 times 0. 0 times infinity times. We talked about 0 times 0. When we have 0 times, it's a multiplication. Okay, 0 times, no, I'm sorry, 0 is not clear. 0 times infinity. When we have this product, we have a problem. Then to summarize, right now, we have 3 kind of problem when it's hard to evaluate the limit. The first is 0 over 0, the second is infinity over infinity, and the third is 0 times infinity. Okay, here, this is the first kind of problem, 0 over 0. Obviously, why? Because the limit of the numerator is equal 0, and also the limit of the denominator is equal 0. The solution, how to overcome this problem, in order to solve this problem, the best way is the following. That means we try to remove this problem, or to solve it. In order to solve it, we apply Hospital's rule. What he said when we have a fraction, this limit is equal to the limit of the derivative up divided by the derivative of the denominator. The derivative of ln x, as you know, is 1 over x, and the derivative of x minus 1, as you know, is 1. Now it becomes 1 over x. However, 1 over x is an easy limit, because when x goes to 1, 1 over x also goes to 1. That's why this limit is equal. Then when we do this action, when we apply this rule, which is called Hospital's rule, we solve the problem. I hope it's clear. Any question before moving? Maybe we did this last Sunday, maybe. But anyway, it's just a review. As I said, we have in sometimes the same, we have in sometimes what we have in sometimes, we have in sometimes a product. As I said, sometimes we have 0 times infinity, 0 times infinity. It's the product, okay? Then what we have to do in order to apply Hospital's rule? You know, Hospital rule works only when we have a fraction, okay? Then the idea is to look the product as a fraction, okay? For example, when we have the 3 times 4, okay, for example, just to fix idea, we can look it like 3 divided by 1 over 4. Okay, is it clear? Then we have to use this way in order to solve the problem. 3 times 4 is equal 3 divided by 1 over 4. Okay. Since we use, when we use this way, we can easily write f times g like the product of 1 over 1 over g. That means we write g like 1 over 1 over g. The 1 over 1 over g is equal g. When we divide the half by 1 by half, it becomes also 2. I'm sorry, g. I have to write g here. Then g is equal 1 over 1 over g. When we use this way, we can write f times g like f divided by 1 over g, or g divided by 1 over f. Which one we have to choose? It depends of the situation, okay? Anyway, we can use the first or the second. However, we have to use the best. What that means, the best way, we are going to look at this later. This is the first example. For the first example, as I said, we have a product here. Is it a hard limit or not? The answer is yes, because the first limit goes to 0, and the second one goes to infinity. This one goes to 0, and this one goes to infinity. Why? Because when we use when we evaluate log something natural logarithm of something small, it becomes large enough. And when we have something small, when we have limit of x is equal 0, then 0 times infinity. That's why it's a problem. That means it's an indeterminate limit because we have 0 times infinity. Okay, negative infinity, but anyway, it's infinity. Small times large, it's hard to evaluate. That means we have to work more in order to do it, to evaluate the limit. Work more for the section that means use hospitals rule. As I said, we can look the product thanks to this identity x equals 1 over 1 over x. We can look this limit like ln divided by 1 over x. Now, it becomes what? It becomes a limit. It becomes something infinity divided by infinity. It becomes the numerator go to infinity and the denominator also go to infinity. Then infinity to infinity, it's indefinite limit, indeterminate limit. However, when we apply Hospital's rule, this is the derivative of ln x. Obviously, the derivative of ln x is 1 over x. But is the derivative of 1 over x, شباب؟ مين ذكرنا اشتقاق 1 over x is equal what? 1 over x prime is equal what? مين معانا؟ تستمعون لي شباب؟ ما شاء الله في 37 طالب. You hear me?
Yes.
What is the derivative of 1 over x? What we have to do? We have to look at like x to the negative. Okay, good. We have the idea is to look at this expression x minus like x minus 1. Then x minus 1 prime. Thanks to your to the formula, we can see it's equal minus x to the negative. As you said, it's equal minus 1 over x squared. Minus 1 divided by x. This is what we have. Then the derivative, remember, the derivative of 1 over x is equal minus 1 over x squared. Here, we use this information. The derivative of 1 over x is equal minus 1 over x squared. And obviously here we can simplify a little bit. Why? Because 1 over x divided by minus 1 over x squared. Is it possible to simplify this or no? Maybe you can evaluate it easily. It's equal negative x. This one is equal. Then it becomes 0. Okay. Now, this is before I said we have two equality, two identity. We can put G down or F down. Why we choose here X down? Okay. In general, we choose the complicated function up. Why? Because when we evaluate the derivative of ln x is better than assume we switch. That means we put x up and 1 over ln x down. When we evaluate when we apply your formula, it becomes a little bit hard and it's not the best way. بمعنى في المطلق نختار الدالة الصعبة نضعها في البسط. Okay? When we have ln or something like that, we have to put it in the numerator and not in the denominator. Okay? Then when we have something hard like ln or sine or exponential, it's better to write it in the what I have to see in the numerator. Okay. Then finally, this is in sometimes I said the 3 indeterminate limit. The fourth one is negative is infinity minus infinity. This is an indeterminate form. When we have a difference between two functions, the first one go to infinity, and if the second one also go to infinity, we cannot evaluate the limit of the difference. It's called, once again, indeterminate. But the hospital rule can solve just a fraction. That's why sometimes we try to write the difference once again as a fraction. Let's see an example. Here we have a problem when we can solve it thanks to hospital's rule. Here this one go to infinity, and this one sec go to infinity, and tan go to infinity. Tan, we have a vertical asymptote for tan, and same for sec. That means we have something like that for the graph of sec and tan. But anyway, it's not this is the important point. For me, we have something large, infinity minus infinity. Then it's indeterminate limit. However, we can write this expression as a fraction. Why? Thanks to by using the fact sec equals 1 over x and tan equals sine over cosine. What we look here in this expression, we have a common denominator, which is cosine x. Here we have cosine x, and here we have cosine x. Then we can write it like 1 minus sine divided by cosine. It's a hard limit, once again. However, this limit is hard. We evaluate it in the same point in pi over 2 negative. This one goes to 0, and this one goes to 0. Then the limit, it was a hard limit like infinity minus infinity. The positive point now, it becomes 0 over 0. Infinity minus infinity. Thanks to some computation, okay, it becomes, thanks to some computation, it was first infinity minus infinity when we cannot conclude. However, thanks to some computation, it becomes 0 over 0. But it's, we have the same problem, because 0 over 0 is also indeterminate form. However, دائما في حل, the solution is the following. Here, when we have 0 over 0, we have a fraction. When we have a fraction, then we can solve this problem thanks to Hospital's rule. That means we have to evaluate the derivative of 1 minus sine, which is negative cosine, and the derivative of cosine, remember the derivative of cosine is equal minus sine, negative. That's why it becomes minus cosine over cosine. Now in pi over 2, what about the limit of the numerator? The numerator goes to 0 because cosine pi over 2 is equal 0. Then it's still 0. However, the denominator goes to 1. 0, and this one goes to minus 1. Then 0 divided by minus 1, it's not an indeterminate form. 0 على 1 goes to 0. Okay? متى المشكل لما تكون 0 على 0. When we have 0 divided by 0, it becomes indeterminate limit. However, here we have 0 over 1, and or 0 over minus 1. 0 over minus 1 goes to 0. That's why we can solve this limit. Then, to summarize, we have 4 forms. The first one is 0 over 0. The second one is infinity divided by infinity. The third one is 0 times infinity. And the last one is 0 times infinity, small times large. And the last one is infinity, negative infinity. In general, we try to solve this problem by going to the first two cases. When we have a multiplication, we try to write it as a fraction. When we have a subtraction, we try to write it as a fraction. بمعنى لما يكون عندي الحالة الثالثة والرابعة نحاول نرجع للأولى والثانية. أوكي؟ تكون قسمة. أوكي؟ بعد هذا القسمة نطبق هوسبيتال رول. أوكي؟ قانون الهوسبيتال. اللي يقول لي الولد تخاف اشتق البسط والمقام إذا وجدت ليميت أمورك تمام. When we do this, we have 0 over 0 or infinity over infinity. Thanks to this, we use hospital's rule in order to solve this kind of problem. This is all for the lecture. في سؤال ثاني في ملاحظات؟ إذا if not نمر في الوقت الباقي نحاول نصلح تمرين من كل sections. أوكي. نسوي التمرين من الكريتيكال نمبرز هذا. من ذكرنا what is the meaning of critical numbers. Critical numbers of the function. What that means. شباب معي؟
when the equation is equal to 0.
Which equation? F prime not defined, f prime of x. X is a critical number if f prime of x is not defined. Okay, f prime of x not defined or equal to 0. Not defined, two ways we have. Not defined, not defined, or equal 0. Defined. لا إله إلا محمد رسول الله. Defined or f prime of x equals 0. Okay, then we have to look at what time it's not defined. This is a critical number. And the other thing is at what time is equal 0. F prime of x equal 0. Okay, defined. F prime of x equal 0. Is it clear, Shabab? F prime of x equals 0. Any question about this? Then, as application, here نسوي أي مثال من 1921-23. بسرعة شباب, as you like. For 23, the best way is to look, we have to look your function like x to the 1 over 9, obviously. When we look at it like that, the derivative becomes, the derivative is equal g prime of x is equal what? Is equal 1 over 9 x to the minus 8 over 9. X to the minus 8 over 9. Is it okay for everyone? At what time it's equal 0? This expression, be careful. Here it's like in the denominator because we can look at like 1 over 9 x to the 8 over 9. At what time it's defined, first of all? At what time it's defined? It's defined everywhere without 0. Then in 0, 0 is a critical number. Why it's a critical number? Because the derivative is not defined. Then 0 is a critical number because the derivative critical numbers. Is it okay? 0 is a critical number. Why? Because in this point the derivative is not defined. We have other critical number. At what time the derivative equals 0? تيجي الاشتقاق هذا 0 هذا يجي 0 ولا ما يجي؟ هل أنه يجي 0 واحد على شيء واحد 1 over something it's equal 0 كيف؟ غير ممكن. This one is it equal 0? No, it's okay. It's impossible. That's why we have just 0 as a critical number. We have just 0. Okay. Then the only critical number for this case is 0. Okay. We have just 0 as critical number. Critical numbers. The only critical number here is 0. Is it clear شباب for everyone? ممتاز. نمر للمثال اللي بعديه. Here this application is like the example done in the slides. Here he wants the absolute maximum. What we know? We have 3 steps in order to complete. First, critical numbers. ناخذ أي مثال شباب. أول شيء ناخذ critical number. Critical number في الكيس هذا لأنه the derivative is defined anyway. Then critical number critical, that means the derivative equals 0. أي مثال نختار شباب؟ Okay. إذا بالنسبة للsecond one, what about the derivative? The derivative is equal, if we want, minus 2 minus 2x. Minus 2 minus 2x. At what time it's equal 0? This is the derivative. The derivative is equal 0. متى تساوي 0 هذا؟ minus 2 minus 2x. It's in minus 1. Equals 0. X equals negative 1. Is it clear? For minus 1 تيجي 0. X equal minus 1. Then we have, to summarize, we have just one critical number اللي هو minus 1. لأنه the derivative is defined, then the set when f prime is not defined is empty, and the set when f prime is equal 0 contain only one element which is minus 1. Then we have one critical number. بعد critical number نسوي ايه؟ نزود ال end point. إذا تذكروا ترجعوا ل 4.1 تجدوا نزود ال end point. We have minus 4, minus 1 and 1. We have 3 points. Is it clear شباب؟ We have 3 points. Critical number will end point. We have 3. What we have to do, we have to evaluate f of minus 4, f of minus 1 and f of 1. نشيك على الاوتبوت حق ال 3 points. f of minus 4 كم تيجي شباب؟ عوض x ب minus 4 هنا. f of 1 تيجي كم؟ f of 1 is minus 2. f of 4 كم تيجي شباب؟ بسرعة f of 4 نعوض ب 4 تيجي 1 minus 24 minus 23 صح؟ f of 1 equals minus 2. What about f of what? f of 1. f of minus 1 I'm sorry. f of minus 1 تيجي كم؟ f of minus 1 تيجي كم شباب؟ substitute تعوض الاكس بالماينس 1 هنا. For example 36. 1 plus 2 minus 1 0. لا 2. لأنه شغلي صح. Here first of all critical numbers 1. Only 1. After that we add the end points. The end point we have 2 here. We have minus 1 and 1. Okay. الإند بوينت بمعنى بداية المجال ونهاية المجال. The end points. When we start, when the interval start, and when the interval end. Here, this is the start and this is the end. And this is the critical number. Then we have 3 points. Minus 4, minus 1, and 1. Check about the output of these numbers. The output is the following. First of all, it's minus 23. صح? What about minus 4? 1. نعوض الاكس بالماينس 4. We substitute x by minus 4. It becomes 1 plus 8 minus 16. تيجي كم شباب؟ 1 plus 8 minus 16. تيجي كم؟ it's not minus 23. مين قال لي؟
minus 7.
يا لطيف تشيلت كل. إذا قلنا في 3 point. قلنا في minus 1 minus 1 صح؟ وماينس 4 و1. نكتب الاوتبوت على طول، ما حكتب minus 4 1. بالنسبة للماينس 1 تيجي كم الاوتبوت؟ f of minus 1 تيجي I have to evaluate f of minus 1. f of minus 1 نعوض الاكس بالماينس 1 تيجي كم شباب؟
1 minus 4 plus 1 تيجي minus 2.
ما يبغى يكتب. Okay, I hope it works. f of minus 1 تيجي كم؟
لا دقيقة أتوقع 6.
لا f of minus 1 نعوض الاكس بالماينس 1 في الاف ما في الاشتقاق هنا 1 plus 2 minus 1 1 plus 2 minus 1 is equal to clear 1 plus 2 minus 1 is equal to f of minus 4 minus 4 كم تيجي شباب f of minus 4 نعوض الاكس بالماينس 4 تيجي كم 1 plus 8 minus 16 1 plus 8 9 minus 16 تيجي minus 7 صح f of 1 f of 1 is equal 1 minus 2 minus 1 is equal minus 2 خلاص هذوما 3 values okay which one is the largest one the largest one is the absolute minimum أصغر شيء هو المينيموم وأكبر شيء في 3 نقاط هو الماكسيموم المينيموم حيكون كم شباب عندي 2 minus 7 minus 2 هذا المينيموم والماكسيموم كم معي شباب الماكسيموم هو 2 المينيموم بالأسود والماكسيموم بالأحمر Is it clear?
Yes.
Then في الوقت الباقي حنحاول نسوي limit على السكشن last section. Try to evaluate which limit we choose. اختاروا limit شباب. أي واحدة من اللي تبغى. 5. Okay, heavy. Here, is it, we have a problem in 5 or no? The answer is yes. Why? Because this one go to 0 and this one go to 0. Exponential x and sine x. Then 0 over 0 is a hard problem. That means it's indeterminate form. Then نقرأ السؤال أول شيء. Find the limit. Use hospital's rule where it's useful, where appropriate. If there is a more elementary method, use it. If hospital's rule doesn't apply, explain why. Let's move to example 5. This is 5. As I said, we have a problem. Then we apply hospital's rule without any problem. Then it becomes limit in 0. Limit in 0. Limit in 0. Exponential x divided by, what about the derivative of exponential x minus 1? The derivative of
cosine divided by cosine.
Divided by cosine, because the derivative of sine is obviously cosine. Exponential x, exponential x divided by cosine. Is it a hard limit now? Or it becomes easy?
It's cosine is, it's fine, yeah, because cosine 0 is 1.
Okay, 1 over 1. It becomes 1 over 1. The numerator goes to 1 and the denominator goes, then it's equal 1 over 1. Because the numerator goes to 1 and the denominator goes, that's why this limit is equal. Then thanks to Hospital's rule, the problem is last one. We can try this one. It's a little bit hard, 13. For 13, it's a little bit hard. Why? Because here we have infinity divided by infinity. I have just 3 minutes, I have to do it. Then what I have to do, I am going to see it's equal limit in the same point in infinity. Okay. دائما في نفس النقطة limit x go to infinity, x go to infinity. About what? نشتق البسط والمقام. لما نشتق نبدأ بالبسيط. المقام اشتقاقه هو 2x. صح؟
3 لن x 1 over x.
3 لن x تربيع. انتبه صديق.
لن x تربيع multiply by 1 over x.
اوكي. لن x تربيع
للكل.
لن x ما فيها x لن x تربيع squared squared times 1 over x. ضرب واحد على x. بس لما تكون ضرب واحد على x هي قسمة على x. Is it clear?
Yes.
When I have to write 1 over x up, I put it x squared down instead of x. It works?
Yes.
Once again, it's infinity over infinity. طبعا I can write 3 over 2 outside. It's a constant. But once again, I have the same problem. But it's a little bit better. Why? Because it was x to the 3, ln x to the 3. Now it's ln x to the 2. Okay. Then once again, I have to apply the same rule. Okay. When I apply once again the same rule, it becomes what?
It becomes 2.
Once again, it's 2x. المقام اشتقاق x تربيع هي 2x. ليه الشباب 3 على 2 وضعتها اوتسايد؟ واضح؟ بس اشتقاق الاكس تربيع هي once again 2x واشتقاق ln x هي 2 ln x تربيع يمصد هي 2 ln x
1 multiply 1 over x يعني الاكس تنزل تحت تصير 2x سكوير تحت
once again تصبح x. اذا تحل الموضوع لسه ما تحل بس
ما تحل ال2 تروح مع ال2
لحظة ال2 تروح مع ال2 لانه الموضوع تحل تصبح ln x على x تربيع تحل ولا لسه؟ not yet.
لسه
لانه this one go ln x go to infinity
over infinity
and infinity over infinity. We have the same problem. However, maybe it's better. It was ln x to the 3. Now it's just ln x. I have to apply once again the same formula. It's equal 3 over 2. Now the problem will be
it becomes 1 over
in infinity once again. What about ln x? What about the derivative
1
of
over
ln
x?
1 over x. What about the derivative of x squared? It's 2x.
So 2x cubed. Squared, sorry.
It will be 2x
squared.
It's equal. Good. Now the problem is because here we have just x, we exclude ln x. We don't have any natural logarithm. It's equal 3 over 4. It's equal 3 over 4. Limit in infinity 3 over 4. Limit when x go to infinity about what? Limit
1 over infinity.
1 over x squared. Limit 1 over x. مع الأسف لا إله إلا محمد رسول الله. Limit 1 over x squared. Obviously, what about this limit? It's hard to evaluate or it becomes easy?
Easy.
Finally, it becomes easy because 1 over x squared, when x is large enough, x squared is also large enough, and 1 over x squared is equal 0. Then this limit equal 0. Then, إذا لاحظتوا شباب, it's very important this kind of application. ln x to the 3 divided by x squared. أول شيء نشتقها مرة أولى. لما نشتقها تصبح 3 ln x تربيع. في 1 على x، بس انتبهوا الواحد على x نزلته الاكس اصبح x تربيع. اذا الليمت دائما انفينيتي على انفينيتي، بس الباور نقص 1. كلير يا شباب؟ الباور it was to the 3 now it's to the 2، والاكس سكوير تقريبا بقيت نفسها لانه constant I can put it outside. نطبق القانون مرة ثانية وثالثة نجد الحل. Is it clear يا شباب؟ إذا أحيانا I need to apply my formula more than one in more than one time. Clear? For example, try to do 17. It's something like that. حنجد 0 بس حنطبق القانون أكثر من مرة. Okay. I hope it's okay. It's if it's yes, you can leave. It's time to leave. If we have any question, more than welcome.